Imagine this. What if black holes are not just the graveyards of giant stars, but fossils older than the stars themselves? What if, scattered invisibly across the cosmos, are ancient black holes born in the first seconds after the Big Bang, silent, invisible, and perhaps passing right through our galaxy, maybe even our solar system, right now? Tonight, I'll take you beyond the edge of imagination to explore the possibility of primordial black holes, the oldest shadows of the universe. When we talk about black holes, we usually imagine the collapse of massive stars, those titans 20 or 30 times heavier than our sun, collapsing in spectacular supernova explosions. But primordial black holes are different. They are not the children of stars. They are the children of creation itself. Born not billions of years ago, but 13.8 billion years ago. In the very first heartbeat of the universe, the Big Bang, the idea is simple, yet radical. In the violently dense plasma of the infant cosmos, regions slightly denser than their surroundings may have collapsed under their own gravity. Some collapsed so much they became black hole-teeny ones, some no bigger than a mountain, some as small as an atom. Yet, with the mass of entire planets, they are called primordial black holes because they come from the primordial universe. The concept was first proposed in the 1970s by Stephen Hawking and Bernard Carr. They asked a daring question. If the infant universe was uneven, full of ripples of density, could those ripples collapse directly into black holes? Unlike stellar black holes, these would not need stars. They would predate stars. They would be the first true structures in the cosmos. For decades, this idea floated on the edge of science, dismissed by some, championed by others. But new discoveries have given it fresh life. So, how would a primordial black hole look? Some might be as small as an atom, yet incredibly massive. Others might be the size of mountains. Unlike ordinary black holes, they might not produce bright accretion disks. They would be invisible, detectable only through their gravitational effects. We would know them not by light, but by absence, by distortion, by their fingerprints on the cosmic microwave background, or by the way they bend starlight through gravitational lensing. Here, the twist. Some scientists suggest that primordial black holes could explain one of the greatest mysteries in cosmology: dark matter. Dark matter makes up 85% of the universe's matter. Yet we cannot see it, cannot touch it, cannot identify it. But what if dark matter isn't made of exotic particles we've never found? Billions, perhaps trillions of them, each one tiny, each one ancient, together forming the invisible skeleton of the cosmos. Here's where it gets stranger. Primordial black holes as time capsules, if they exist. They are fossils from the earliest universe. Studying them would be like studying the DNA of creation itself. Seeds of galaxies, some astronomers wonder, could supermassive black holes, the giants at the centers of galaxies, have grown from primordial seeds. Tiny black holes merging and devouring matter until they became millions or billions of solar masses. Microscopic explosions, according to Hawking, small black holes should evaporate through Hawking radiation. If primordial black holes were tiny enough, some might be evaporating right now, bursting into brief, powerful explosions of energy at the edges of the universe. Passing through Earth, a primordial black hole the size of a pebble could weigh as much as Mount Everest. If one passed through Earth, it wouldn't swallow us whole, but it might punch through like a ghostly bullet, leaving seismic scars. Could this explain strange signals we have not yet decoded? As a space explorer, I've learned that the greatest mysteries often hide in the smallest cracks of reality. Primordial black holes are not just theoretical curiosities. Modern telescopes, like the James Webb Space Telescope, and gravitational wave observatories like LIGO and Virgo, are now powerful enough to test whether these ancient ghosts exist. In 2016, the first detection of gravitational waves ripples from merging black holes sparked a new question. Were these black holes remnants of massive stars, or were they primordial black holes colliding after billions of years, drifting silently through the cosmos? The data is still debated, but the possibility remains. And here is the thought that humbles me most. If primordial black holes are real, they are older than the first stars, older than the first galaxies, older than any atom in your body. They are the universe's memory, silent witnesses to creation, proof that chaos itself can give birth to order. Perhaps they are not monsters, but storytellers, fossils of a universe that began in fire and quantum turbulence. And perhaps within their silent gravity lies the missing piece of the puzzle, the secret that could unite gravity with quantum mechanics, the large with the small, the known with the unknown. So here's the truth. Primordial black holes are not just an idea. They are a possibility that could rewrite everything we think we know about the universe. They may explain dark matter. They may have seeded galaxies. They may be exploding in distant space, even now. Or they may be passing silently through our solar system, older than time, invisible to our eyes. They remind us of one thing: the universe still keeps its deepest secrets close. And maybe, just maybe, the answers to the greatest mysteries lie not in the stars, but in the shadows older than the stars themselves. If this journey left you in awe, hit that subscribe button. Join me on Black Hole Secrets, and together, Let us keep exploring the mysteries of space, because the story of the universe has only just begun.